ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజ్ చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్లో కూర్చొని చదువుకున్నంత సీరియస్ చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ని పరీక్షించుకునే కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
Welcome back, students. Good morning to all of you. We are dealing with mensuration chapter in class 10. In that, combination of solids is being taken here. That too, long answer questions which are very important from the examination point of view. 8 mark questions I am dealing with. So in this process, in our previous classes, we learned so many problems based on a cube joined with another cube, a cuboid formed, and a capsule problem and a tent problem, like that. Now, in today's class, I am going to take some problems which are already in your exercise. 6th problem I am taking up. 6th one, a sphere, a cylinder and a cone have the same radius. Find the ratio of their curved surface areas. This is the question. In this question, it is comparison of 3 solids. What are the 3 solids given? A sphere, a cylinder and a cone. What is the common part of all these 3 figures? Let me draw the figure first. A sphere. First, a sphere. I am drawing a sphere. So to draw a sphere, all that you need to do is draw a circle and put it like this. It's a 3-dimensional object, so you can darken this portion with your pencil in examination. So it looks as if it is a 3-dimensional figure. I am trying it on the board with the chalk, but you can be very particular in drawing this 3-dimensional figure in your notebook or in your examination page very comfortably. This is a sphere. What is the dimension given for sphere? Sphere. What is the radius? R. This is first one. Second one is a cylinder, and cylinder too has the same radius. Draw the cylinder also like this. This is the cylinder. What is this? Right circular cylinder. In fact, it is a right circular cylinder. As I told you in our previous lessons, whenever you discuss about the cylinder, it is to be considered as right circular cylinder. Right circular cylinder means the base and the height are perpendicular to each other. For the right circular cylinder also, what is the radius given? R. This is the radius. I marked it here. This is the radius. Even this is also considered to be radius. And this has got height also. Height is represented by generally h. Next, what else is given? A sphere, a cylinder and a cone have the same radius. A cone needs to be drawn. What do you mean by a cone? It's again a right circular cone. A right circular cone means the height, if you look at that, it is exactly vertical to the horizontal. When you place it on the horizontal, it lies exactly on the horizontal such that the height, the vertex of the cone, and if you drop a perpendicular here, it is exactly perpendicular to the base. So like that a right circular cone is given. RC cone I am writing here. RC stands for right circular cone. RC cone, RC cylinder. RC cylinder stands for right circular cylinder. Now for the cone, what are the dimensions given? Radius is the same, or height is the same, h, and slant height is extra for this. This is L. Now the question is that a sphere, a cylinder and a cone have same radius. Find the ratio of their surface area, curved surface areas. So we know that find the ratio of their curved surface areas. So here we need to find the question is a little changed here. Is it the volume or not? We'll just let me check it up once again. The question says that the comparison is for volumes. Find the ratio of their volumes, not CS areas, volumes. What is the comparison we have to do? Comparison is volume of all the three figures. Diameter of the sphere is equal to the height of the cone. That is what is mentioned already in the problem. Diameter of sphere is height of cylinder and cone. This is the question. So a sphere is drawn with the radius r. What is this? This is the diameter. When you look at this, it is the diameter which is 2r, which is equal to h in the case of right circular cylinder. The height is equal to the height of the sphere, which is the diameter. The height of the right circular cone is also equal to the same, h is equal to 2r. This is h. Here also h is equal to 2r. Now we need to find the volume. Shall I call the volume for the sphere as V1? Yes. Volume of the sphere is taken to be, what is the formula for the volume of the sphere? 4 by 3 pi r cube. This we call it as 1. So we have to compare this. And here I am writing this volume as V2. I am not writing the word here, it is V2. What is the volume of a cylinder? Pi r square h is the formula. But pi r square, what is h? Is equal to 2r, which is 2 times the radius, which is the diameter. Next we get 2 pi r cube. Next, slant height is L. Of course, it is not required here. And volume is taken here as V3. What is the volume of the cone? It is 1/3 of the volume of the cylinder. So the cylinder volume is pi r square h. So it is 1 by 3 pi r square h. So it is 1 by 3 times pi r square times h. What is h? 2r. 2 by 3 pi r cube. So now we got the three volumes. I am numbering them as V1 is 1, V2 is 2, V3 is 3. Now what is that you have to find out? Find the ratio of their volumes. Ratio is V1 is to V2 is to V3. What is V1? 4 by 3 pi r cube is to 2 pi r cube is to 2 by 3 pi r cube. So we have to look at the common terms here. Can you see r cube in common in all? Yes, I am rounding it off. Means what? They are all cancelled. 4 by 3 pi is to 2 pi is to 2 by 3 pi. Again, shall we cancel pi too? Yes. I am cancelling pi also, which is the value irrational number 22 by 7 or generally 3.14. So that is also cancelled. 4 by 3 is to 2 is to 2 by 3. Look at the LCM portion, denominator portion is 3. So in order to have 3 here as the denominator, we have to multiply this by 3 by 3. 2 into 3 by 3 is to 2 by 3. 4 by 3 is to 2 into 3 is 6 by 3 is to 2 by 3. Can you cancel 1 by 3 throughout? Yes. It is giving 4 is to 6 is to 2. Can you cancel 2 again? Yes. 2 into 2. 2 is to 3 is to 1. So, when you look at the volume, this is more. 3 means 3 times. This is 2 times. This is 1 time. So, the volume when you compare, it is 1 time volume is 2 times to sphere. Sphere volume is double the volume of the cone, and right circular cylinder volume is 3 times volume of the cone. So this is the problem, 2 is to 3 is to 1. This question was asked several times and it is important problem even from the examination point of view. As a formula also it is important. It is a 3-dimensional figure. You please darken it like this so that it looks this way. So darkening this gives the 3-dimensional feeling. So when you present the problem like this impresses the viewer. So you will get good marks. A sphere, a cylinder, a cone, volumes are taken. They are called as V1, V2, V3, and the V1 is taken from here, V2 is taken from here, V3 is taken from here. The ratio is simplified, so you get 2 is to 3 is to 1. This is the answer. You can take down this as the important problem. So we will move to another problem after you take down this. Shall I explain it once again? I don't think it is required. Just take down this problem. It is a very useful problem and important problem.
Hello students, myself is Sanjay Kumar Singh and I did my B from Birla Institute of Technology, Misra, and I am having 18 years experience of teaching. Now I am associated with KVC classes. Now here the advantage which you people are going to get, that there is a technical pool of faculty, mostly from IITs. So this is one of the biggest enabler for achieving your success. The second best thing is that doubt classes and all, they are conducted in the presence of faculties. So third is that your entire curriculum, timing of teachings, all is being monitored by ITians and NITians. So come here and join us.
I'm sliding it. We'll take another problem. Now I'm doing some problems from exercise. A hemisphere is cut from the face of a cubical wooden block. Look at the beauty of the problem. A word problem is written from mensuration chapter in combination of solids like this. Look at the problem. Let me write the problem. Afterwards, I will explain the problem. A hemisphere is cut out from one side of a cubical block such that the hemisphere is equal to the hemisphere is equal to the length of the cube. So that the diameter, such that the diameter of hemisphere is equal to the length of cube. Determine the surface area of the remaining solid. Determine the surface area of the remaining solid. You must understand the question. The question is a tricky question. You should understand the question. A hemisphere is cut out, carved out. తెలుగులో చెప్తాను. ఒక వుడెన్ బ్లాక్ తీసుకుని దాన్ని చెక్కేశారు, తీసేశారు. ఎలా చేశారు? ఏ హెమిస్ఫియర్ ఈజ్ కట్ అవుట్, హెమిస్ఫియర్ లాగా తయారు చేశారు. ఫ్రమ్ వన్ ఫేస్ ఆఫ్ ద క్యూబికల్ వుడెన్ బ్లాక్ సచ్ దట్ ద డయామీటర్ ఆఫ్ ద హెమిస్ఫియర్ ఈజ్ ఈక్వల్ టు ద లెంత్ ఆఫ్ ద క్యూబ్. డిటర్మైన్ ద సర్ఫేస్ ఏరియా ఆఫ్ ద క్యూబ్. What is the dimension given? Each cube length is given as, side is given as u units. The diameter is 2 times a. Am I right? Diameter is equal to a. So diameter is equal to a. Therefore radius is 2 times a, or radius is diameter by 2, d by 2. Diameter is already given as the length of the cube a, so a by 2. Radius is a by 2. What is the total surface area of the cube? 6a square. So I am drawing the figure first. Look at the figure. It's a 3-dimensional figure. Look at the easy way of drawing the figure. Whenever you have to draw a cube, draw two squares, one behind the other, projected like this. So with the same kind of dimensions, just join this. Then you will get a cube like this. So what is the dimension given? A units. Side is a units, length is side, length is a, breadth is side a, and height is a. What is the cube? A cube has all the 6 sides equal to each other. Length, breadth, height. And length here, breadth here, height here. So when you look at that, there are 6 surfaces. All the 6 surfaces look like a square, equal square. So now a hemisphere is cut out. So దీనిలో నుంచి తెలుగులో చెప్తే మీకు అర్థమవుతుందని చెప్తున్నాను. ఇలాంటి క్యూబ్ తీసుకొని ఈ క్యూబ్ని చెక్కాలి. ఎలా చెక్కాలి? హెమిస్ఫియర్ ఫామ్ అవ్వాలి. అంటే ఈ కార్పెంటర్స్ చేస్తారు చూడండి, చిజిల్ పెట్టుకుని చెక్కేస్తూ ఉంటే దీన్ని ఈ కార్నర్స్ ఇలా తొలిచేస్తూ ఉంటే చిన్న హెమిస్ఫియర్ ఫామ్ అయిపోతుంది. ఎలా ఫామ్ అవుతుంది? ఇలా హెమిస్ఫియర్ ఫామ్ కావాలి. సో ఈ హెమిస్ఫియర్ is checked out or cut out from a wooden cube. ఇలా చేసిన తర్వాత చూడండి కొంత వుడ్ పార్ట్ వేస్ట్ అయిపోతుంది. సమ్ వుడ్ పార్ట్ ఈస్ బీయింగ్ cut out. So what is the surface area of the remaining solid? So after this is being cut out, what is the structure formed? What is the solid formed? The solid formed is a hemisphere. For this hemisphere there is curved surface area, and for this cube also there is a total surface area. So you have to find the surface area of the remaining solid. Whatsoever portion is being cut out, for that what is the surface area is a question. So drawing the figure is also very important. This is a, diameter is taken to be a, diameter is a. So this is the radius, r is equal to a by 2. So this is a cube, this is a hemisphere. Draw the figure like this. Hemisphere means half the sphere. So for this side is a, this diameter is side of the cube which is given as a. Therefore radius is a by 2. Draw the figure. Now we will work out the remaining thing. What is the total surface area of the cube? We know that total surface area is 6 6 into a square. Curved surface area of the hemisphere is 2 pi r square. 2 times pi into a square by 4. So it is 2 pi a square by 4 or pi a square by 2. Square units. This is the question. After removing the hemisphere from the cubical wooden block, surface area of the remaining solid is total surface area of the cube plus surface area of the hemisphere minus area of the top of the hemispherical part. So this is required area is total surface area of cube minus CSA plus CSA of hemisphere minus area of the top which is 6a square total surface area, which we got it, pi a square by 2 plus pi a square by 2 minus pi a square by 4. After simplification, you will get this as 6a square plus 2 pi a square minus 2 pi a square minus pi a square by 4. So it is 2 pi a square minus pi a square by 4. 6a square plus pi a square by 4 is the answer. So take down this problem. One done. Let us take one more problem. Exercise 10.3. Surface area of one more combination figure is there. Let me explain that figure problem. Afterwards, we will do 10.3. There is a problem like this. A shed is in the form of, this is a worked example, page number 256 in the textbook. A shed is in the shape of a cuboid surmounted by a half cylinder. The dimensions are 7 meter into 15 meter and height is 8 meter Find the volume of the air. Further, suppose that the machinery, there are two parts. Let me add those two parts later in the question. So first you try to understand the question. A cube is surmounted. A cuboid is taken first. What is a cuboid? Look at the cuboid like this. Cuboid has 3 dimensions in a different way. This is length, this is height, this is breadth. A cuboid, and it's surmounted by a half cylinder. Half cylinder means what? So when you look at the cylinder like this, I am drawing a figure like this, a cylinder here. A cylinder is cut and the cut portion is surmounted here. So you have mount cylinder like this. So look at this, it is half of the cylinder. When you look at the cylinder looks like this. So cut it into half, and this half is being taken and surmounted on the cuboid. So this is height, this is length, this is breadth.